Hello guys, this is Paul maketoorder from TopTechBoy.com, and we are here today with lesson number 35 in our legendary new and improved series of tutorials on the Arduino microcontroller. I will need you to pour yourself a large mug of iced coffee, and I will need you to get out your Lego starter kit, the super starter kit. If you don't have one, check out the description below. The link will take you to a kit on Amazon for $35. You'll get all the hardware that we are using in this entire series of Arduino tutorials. And seriously, it does help a little bit if we are working with the identical hardware. All right, what are we going to learn today? We are going to learn about stepper motors. This is a monster. You don't have one of these in your kits. This is like a mini monster. This is like Papa Bear, Mama Bear, and then on the Arduino kit you kind of have Baby Bear. But the thing is, the one that comes with the kit is suitable for learning on, and so we'll be able to learn on this one, and then if you know how to use this one, you can come in and you can use the bigger ones. But let's talk a little bit about stepper motors before we jump in. There's some very important things to know about stepper motors. One of the really good things about stepper motors is they allow for very precise control. You don't just hit it with a voltage and let the thing spin. The way you turn it is you kind of click it like one step at a time, all right? And different stepper motors have different step sizes, but a step size can be a fraction of a degree, like a tenth of a degree. And so one of the characteristics of a stepper motor is you have very precise control of position. The second characteristic of a stepper motor is at low RPMs, you have very large torque. And so you can move things very precisely and you can move them with a large amount of torque. Now, we have done motion. In some of our earlier lessons, we learned how to use a servo. But one of the things about a servo is you don't have that precise control of position. Most of them don't have that much torque. And most of them have limited ranges of motion, 0 to 180. The advantage of a stepper motor is it's really easy to use. The disadvantage is can't make it go all the way around for most of them. Limited range and not that positionally accurate and not that strong. So if you need something like that, you want to move to a stepper motor. These are the disadvantages of a stepper motor. They're kind of tricky to use. They draw a whole lot of current, and so you cannot power a stepper motor off of the Arduino. Even for these small ones, you cannot power them off of the Arduino. You need an external power supply, and luckily you've got one here in the Super Starter Kit. The thing also to know is that it's very tricky to get these things working, and so the parameters that one stepper motor uses are not the same as the parameters another stepper motor uses. So you actually got to open up the instructions and read and look at the data sheet. The other thing that you have to keep in mind that's very important on these things is that you've got to use a stepper motor driver that matches the stepper motor that you're using, because like this is a little stepper motor driver made for small stepper motors. If I tried to run this one off of this, then I could run into trouble. I could burn out this driver or cause problems with the motor. Similarly, you've got to make sure that your power supply will generate enough current to run the stepper motor driver to run the stepper motor. And so the nice thing is with these parts in the Lego kit, they're all matched up. This has enough current, this can drive this, and it will all work out fine. But just be aware of that. Be aware of that you've got to be a little bit more mindful and not just go in and randomly plug stepper motors into stepper motor drivers. Now, these big ones, like this one, this one, there's a part called an easy driver, and the easy driver will drive these. This would be something that would be used like on a 3D printer. So applications of stepper motors would be things like a CNC machine where you've got to move a cutting tool around that's kind of might be large and heavy, so you've got to have a lot of torque, and then you're doing precision work, so you got to have a lot of torque and high precision. And so 3D printers and CNC machines, laser engravers, things like that use stepper motors like this. But stepper motors like this size will run off of something called an easy driver, and then they've got something called the big easy or the big easy driver that can drive these bigger ones. But just make sure that your driver is designed for the stepper motor that you're going to use. All right, enough of this nonsense. Let's move on. What you will need for today's project is you will need the power supply out of the eLego kit. You will need a switch. You will need your stepper motor driver. You will need your stepper motor. You will need the Arduino. You'll need a 9-volt battery. My 9-volt battery that came with the kit, I ran it out, so I had to get another 9-volt battery. And then you need the little clip that allows you to plug the 9-volt battery into the power supply. And lucky for you, it's your lucky day that that clip itself is also included in the starter kit. And then you need this this ribbon cable. So let's jump right in and get going on this project. And one of the first things that I want to tell you is, and this is not just something you're learning for this project, this is like one of the #1 reasons that I find that more complicated projects that people are working on don't work. When you have a lot of different components, you have to make sure that they all share a common ground. And so like if you look over here, Arduino has a ground and you're going to start plugging things into Arduino. You've got to make sure that the Arduino ground is connected to the stuff that you're using over here. Now let me maybe start with showing you how to plug in this power supply into the board. You could plug it in this way, or you could turn it around and plug it in over here. But what you have to see is that, do you see how these power rails and ground rails are marked like this one is plus, this one is minus, this one is plus, this one is minus? Make sure that you put it in a way that matches the direction that it's plugged in. So here in this direction, this is plus, and that goes into plus. This is minus, that goes into minus. This is plus, that goes into plus. This is minus, that goes into minus. Because if those labels don't match these labels, it would be very easy for you to plug something in wrong. And then you see that it just plugs in very nicely there. And you've got kind of like plug, 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 and plug, and that all plugs in. Now, the first thing I want to do, because it's the easiest thing to forget, is to plug a ground wire over to Arduino so everyone agrees where ground is. So notice I'm putting it in this minus row. The minus row is coming over to G and D on the Arduino, and so now everybody agrees where ground is, and that's very, very important. Okay, what else do I need to do now? Well, I guess that I need to begin by hooking the stepper motor up to, so we're going to hook the stepper motor up to the stepper driver. If you notice, there's only one direction that this will plug in. You've got those notches that go in these grooves, and so there's only one direction that this will plug in, where the little raised things go in those little notches, and so that is plugged into the stepper motor. Now we need to hook the stepper motor driver up to the Arduino, and that's where this is going to come in. Now the key thing is that you need to get these in the right direction. And what you need is you need IN1 on the motor driver to go to pin 8, IN2 to pin 9, IN3 to pin 10, and IN4 to pin 11. Okay? And I like to do that by using this ribbon cable, and then I'm going to start with the outside one, which for me is black. Your colors might be different, but you've just got to make sure the right one goes to the right one. So my first one is going to be the black into IN1. Then I'm going to put, for me, the next wire is white into IN2. For me, the next one is gray into IN3, and then purple into IN4. There. Okay, so let me see if I can show you that. So you see I got 4 wires, black, white, gray, purple, and it goes into respectively IN1, IN2, IN3, IN4. Now coming over here, remember it all starts with, don't come out of there, okay. It all starts with black, and where did we say that black needs to go? It's going to go into pin 8, and then white, the next one, is going to go into pin 9. So I have pin 8, pin 9, and then the next one is gray, is going to be pin 10, and then the last one is purple, which is pin 11. And then that, for me, will put things, what is this one? We had an error, okay. Black into pin 8, and I had grabbed the wrong wire. So let's look at that. Black into pin 8, white into pin 9, gray into pin 10, purple into pin 11. And then we still have our common ground wire. So that is looking good. Now coming back over to our driver, you can see that we've got to power the driver here. And we have 5 volts that it wants. Well, it says it'll take between 5 and 12, all right? But the negative is the outside one. And so let's look very carefully here. Do you see this first pin is negative? And so I am going to have to put another wire, which is going to be my purple wire, or my blue wire on that outside one. The blue one on the outside one. Where do I need to take the blue one? On the other end? On the other end, the blue one needs to go to the negative, which is that ground rail. Okay, the ground rail. And now what am I going to need? I'm going to then need the second outside one. Okay, and that is going to be my next wire, which is my green wire. And I need to take that to 5 volts. This is where it gets really important. This green wire is 5 volts, not the 5 volts on the Arduino, because you cannot power this whole thing off of the Arduino. It has got to come from the power supply. So I put it on the power supply rail, and I'm really trying to do this where you can see it. Okay, so you see the plus, the power supply rail. Do you see that? Green to the plus 5. So now, let's see what we have here. Okay, so now let's kind of plug this thing in. So I'm going to plug my battery in. And then I'm going to plug my battery into my power supply. And what happens? Absolutely nothing. Well, realize that the power supply has a push button. And if I push the button, look at that. Happy little green light comes on. And then look at this. I've got happy little lights coming on here. And your lights might not come on here if you haven't got the thing programmed up yet, so don't worry about that, but you should see a light there. Okay, so I have got, let's think about this. I've got the motor connected to the driver, and I apologize that this ribbon just will not get out of the way, but the motor is connected to the driver. The driver is powered through the power supply through this rail, these rails. Power supply is turned on, and then I have got pins 8, 9, 10, and 11 hooked up. All right, pins 8, 9, 10, and 11 hooked up. So let's come over here. I actually think we are probably ready to start coding now. This is plugged in, 4 pins, power. Coming over to power, and guys, make sure that you're using this one that's labeled 5 volts where the jumper is on 5 volts. I think this thing comes where this other rail is at 3.3 volts. Make sure that you're hooked up to the 5 volts. And so now let's get all this stuff up here, and it is really annoying to get all this stuff where you can see it. Okay, now we are ready to start coding. So let me come over here to a coding view. Like this, so you can see me and you can see what I'm typing. So what do we need to do in this project? The first thing that we need to do is we're going to run the stepper motor, so we need to load a library. And I think we talked about this on the servo lessons, how to load a library, that it is the pound include. And in this case, which library? Well, you want to open your, let me get this out of the way here. You want to open your triangular bracket, and you're going to say stepper.h, so you're going to load that. And if you installed the software with me in lesson number 1, you will already have this library, so all you got to do is load it. Remember, on an include, it is one of the only steps that you don't put a semicolon on the end of it, strangely enough. Now, what do we want to do? We've included that. Now we want to, we've got to tell it a parameter of our stepper motor, and that's for a particular stepper motor, how many steps for that motor make up a revolution. And for this stepper motor, which is the 28BYJ-48 by Ross, ROHS, that number is 2048. So I'm going to say steps per revolution, is equal to 2048. You've got to get that off the spec sheet for the motor that you're using. It's not always going to be 2048, and 2048, in my experience, is a little bit of an unusual one to use. Okay, now what we also need to do is we need to create the stepper. Okay, so we're going to use the command stepper from the stepper library, and then I'm going to call it my stepper. That's my stepper motor, my stepper. And then I need to tell it, for this motor, what are the steps per revolution? Steps per revolution, which we set to 2048. Okay, and now I've got to give it the pin sequence, and this is going to be 8, 10, 9, 11. And the reason that is true, is because that is what works for this stepper motor with this driver connected to the pins the way that I connected them. That is not always going to be true. If you're using a different driver or you're using a different motor, you're going to have to go in and you're going to have to figure out what that sequence is. I can't tell you a magic formula that will always work for everything. All right, now we come to the void setup. It's usually a good idea to do a serial.begin in case we need to do some troubleshooting and printing some stuff out. That looks good. Then what we are going to need to do is we're going to need to tell the stepper motor how fast we want to go. So I'm going to say my stepper.set speed, and let's go mote speed. Well, if I'm going to use mote speed, I better come up here and define it, right? And ooh, I forgot to put int here. I'm sorry. I hope you guys were yelling at me at that. Okay. And then I need an int, and mote speed is going to be equal to, I am going to say 10 RPM. And understand that these stepper motors you can't run real fast, and so this one 10 is a pretty good clip for it. So then I come down here to mote speed. Now it knows what mote speed is, and so that looks pretty good. I've got that set. All right, what I need to do in the void loop, well, I am going to do a I'm going to tell the thing to move. I'm going to now move it. And so what I'm going to do is I'm going to say my stepper dot step. I'm going to tell the stepper motor to step. How many steps is it going to make? Whatever number I put in here. If I put 1, it's going to do 1 step, which would be about 1/10 of a degree, because if for this motor 2048 steps make 1 revolution, then 1 step would be about 2/10 of a degree. So I want it to go 1 full revolution, so I would just put in here steps per revolution. This is just for demonstration. You could put in here whatever you wanted, okay? And then what I'm going to do is I'm going to delay by delay time. Well, I better go set that up there, give that a value. So I'm going to say int delay time is going to be equal to 500 milliseconds. And then that's going to make 1 revolution in the positive direction. I'm going to want to make 1 revolution in the negative direction. So my stepper dot step, and I want to go minus steps per revolution. And that will make it run backwards because I put the negative in there. And then what do I want to do? I want to delay by delay time, and then it's going to loop. So it's going to make 1 revolution in the positive direction, 1 revolution in the negative direction, theoretically. This is really a lot of complicated stuff here, so it makes me somewhat nervous, all this stuff, whether it is going to run or not. And so then let me also, just so we can see, get a little piece of our Pookie and put it on there, so we will have something to look at, like such. Nice piece of Pookie, which will stick anything to anything. And then I have a nice little arrow, and we will put the arrow on like that. Okay, so now let's download this. Hold your breath, please. Oh. Download it, and look, giddy up, look at that. All the way around once, changed direction, went backwards. Did you see that? We got a stepper motor running here, man. We have got a stepper motor running. Look at that. And look, it looks like it's really making 1 revolution. Okay, why is it making 1 revolution correctly? Because we knew that this magic number should be 2048. Wow, look at that. Look at that. All right, so let's play around with some of these parameters. Don't change this parameter because that's particular for this. But what if we came down? I'll tell you what I'm going to do. I'm going to time this and see if we are really at about 10 RPM. So I'm going to time it. So when it stops, I'm going to start my timer. Okay, I started it. How long does it take to go around? Look at that. 6 seconds. It took 6 seconds. So 60 divided by 6 is 10. It is going 10 RPM. So everything is behaving beautifully, like what we expected. What if we came down here and instead of going steps per revolution, what if we went steps per revolution divided by 2, saying that we want to go half a revolution? Now let's see what happens. Boom, made to order, half a revolution. Now let's see, let's go back to 1 revolution. And let's go a motor speed of 2. Let's go a motor speed of 3 revolutions per minute, and then I will time that and see how it works, okay? Okay, look at that. It's going to go all the way around, slower because we slowed down the RPMs. Look at that. Okay, and it is going to stop. Look at that. 20 seconds, which would be 3 rotations per minute. All right, guys, we have got our stepper motor running, and now it's time for me to give you your homework assignment. Your homework assignment is to incorporate this little button into the project, and this is what I want. I want the motor to run forward, not one revolution, but to just run forward continuously forever. Run forward continuously. But if you press the button, when you press the button, it runs backwards. And you press it again, it runs forward. So this button is going to toggle you from clockwise to counterclockwise. And every time you press the button, it switches direction. I will give you a hint. If you are not sure how to do that, we played around with those buttons. If I can find my mouse, we played around with those buttons in lessons. I believe the last lesson we talked about it, lesson 33, and then also we talked about the buttons, it looks like, in lesson 27 and lesson 28. But try to do it on your own. Okay, try to do it on your own. And then when you come back, I want you to pause the video. When you come back, I'll do it and you can do it along with me. But man, you're never going to really learn how to do something if you're just following what I'm doing. I've taught you enough in these lessons to do this on your own. I want you to go away and do it on your own, and then when you come back, you can see how I did it. Make it work, though, without watching me. Leave me a comment down below that you were able to make it work without watching me, and then tell me you did it the way I did it, you did it a better way, or you did it a harder, more complicated way. Okay, you guys go pause, go do it, and then come back. Some of you didn't pause, did you? You're just going to continue to copy me forever, aren't you? You're just going to copy me forever. All right, well, anyway, nonetheless, we are going to move ahead. So what we are going to do is we are going to come over here and we are going to get this button hooked up. Okay, we're going to get the button hooked up. And I'm going to use the hack that I talked about, I believe, in lesson number 34, which allows us to do this without an external pull-up resistor. And so I am going to come to the left pin of the button, and I'm going to come to pin 2 on the Arduino. All right, and pin 2 on the Arduino. I think I just unplugged my stepper motor, and so I'm going to be very careful that green goes to 5 volts. Green goes to 5 volts, and blue goes to ground. Okay, yeah, and it's running again. So accidentally pulled that thing out as I was hooking up the button. So one leg of the button goes to pin 2 on the Arduino, and then the other leg of the button is going to go to ground, and this is this common ground. Right, we got all of our grounds hooked together, so I put it on the ground rail. So now the button is hooked up. Now we've got to code it where the button actually does something. So let's come over here, and what I'm going to do is, all that code up there was for the stepper motor, and so I'm going to come down to a couple of, just leave some space there. And then if I'm going to use a button, I've got to have a button pin. So I'm going to say int button pin. And where do we connect the button? We connected it to pin 2. Okay. Now, remember how I'm going to make the motor run in 2 different directions? So I've got to keep track. I've got to have a variable that's telling me whether it's going in the positive direction or the negative direction. And so I'm going to have a variable called motor direction, and in my mind mentally, +1 means it's going in the clockwise direction, and -1 means it's going in the counterclockwise direction. So I will start it out going clockwise, but this variable will keep track of which direction the motor is going. Got to keep track of that. It's kind of like dropping a breadcrumb that helps you get out of the forest. You've got to remember which direction your motor is going. Now also, I've got to read the button val, but for this assignment you were to make it toggle. So just press release, it changes direction, press release, it changes direction, press release. It's toggling between 2 states, and therefore I need to have a button val new, And what that is where you are presently. That's whether the button is pressed or not pressed. That's the present state of the button. And then I'm also going to need to know on the last time through the loop, where was the button? And so that would be button val old, because if we were up and went down, that's when we want to change direction. So we've got to keep track of where the button was last time and where the button is this time. And since the first time through I can read the new value of the button, but there won't be an old value, so I need to give it something. So I'll just put in, to get the thing started, say that the old position of the button was a 1, which is basically not pressed. And that will kickstart the thing without having any errors. Okay, now we have got to, all right, we set the stepper up already. So now in the serial.begin, I've got to do that little hack on that pin where I can make that button work without an external pull-up resistor. And if you remember, man, this thing is kind of falling over there. If you remember, the way you do that is you set the pin mode of your button pin to input. So you tell it it's going to be an input, so you can do a digital read from it. And then this is the crazy thing that I think I talked about in the previous lesson, which was, man, this is hard to see this. The previous lesson was lesson number 34. I showed you how to do this little hack. You do a digital write to button pin and you make it high. That's kind of crazy. You said that it was going to be an input, but then you wrote to it high. Well, when you write to it high, it puts 5 volts on it, and when you do the pin mode, it puts that pull-up resistor in there. So you kind of end up with what you want if you do this. If you don't understand it, go back to that last lesson. All right, now we have got motor speed. We already did that. We turned the serial port on. We got that all set up. Okay, let's come down to our void loop. In our void loop, what is the first thing you want to do? Well, you got to figure out where the button is. So how do I do that? I need to do a digital read of button pin, right? And where do I put that? Well, this is the fresh new value. So we put this button val new equal. So this is the fresh new read of where the button is. It's the fresh new read of where the button is. Okay, so now if button val old equal 1, so last time around, the previous loop, the button wasn't pressed, it was up, okay? And if button val new equal 0, this represents a transition. Last time, nobody was pressing the button. Now the button is pressed. That means the button has been pressed. In that case, you want to change directions. Now you'd say, well, why not just say if it's 0? Because what if I pressed it and held it down every time it's 0? If you said switch directions every time it's 0, you're going to press the button, it's going to read. It's going to be reading 0, 0, 0, 0, and it's going to go like this, okay? So the only time you change direction is if you were up last time and this time down, and then you switch directions. I hope that makes sense. So what do you do if button old val equal 1 and button val new equal 0? That means the button's been pressed. You want to change motor direction. So motor direction is equal to motor direction times -1. And I'm going to put parentheses just because I can. I'm a math teacher. I like parentheses. Motor direction, that is crazy. Yeah, that's good. And then motor direction is motor direction times -1. That is proper, just like that. Okay. Motor direction is motor direction times -1. You know what's happening over here? Our battery is running down. And so what I am going to do is I am going to unplug the battery, and I have one of those wall warts that's 10 volts and has the right plug on it. So we are going to go with that because our battery was running down quickly. These things draw a lot of current, and so they will chew your battery up. Okay, so that's working like a charm now. So remember, +1 means you're going in the positive direction. -1 on the motor direction means you're going in the negative direction. So how can I switch? I can take motor direction and multiply by -1, which means if I was going this way and I multiply by -1, I'm going to be at -1 going the other way. Then -1 times -1 is going to be +1. So -1 times motor direction is going to be a clever little way to toggle this thing, okay? So motor direction is motor direction times -1. Now I have the direction right. Now what do I do? Just my stepper dot step. Remember that command? What do I do? Well, I just go one step, motor direction times one step. So if motor direction is 1, I'm going to go one step in the positive direction. If motor direction is -1, I'm going to go one step in the negative direction. So it's just going to be clickety, 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 clickety all the way around, okay? And then when I press that button, I'm going to multiply motor direction by -1, and it's going to switch direction. Does this make sense? Oh my goodness, I hope this works. Hold your breath, please. Boom! At least it's working. At least the thing is going. Okay, let's come up to the full view here. All right. So at least the motor is spinning. Okay, and I got to make sure that I don't pull out any of these wires. All right. Do you see the little switch? The moment of truth. The moment of truth. Okay. The moment of truth. I press the button. Boom! Look at that. Giddy up. You see that? I changed direction. Let's try it again. Back to the positive. Ooh, I pressed it twice. Okay. You know what I forgot to do? You know why this isn't working? I forgot a very important step. I forgot a very important step. Did you guys see what I forgot? What do I need to do? My button val old is equal to button val new. All right, so this is what I forgot to do. After you get to the bottom of the loop, that new button value, it's stale now, it's old, it goes into old, and then you come up here and you get a new button val new. And if you don't do this, it doesn't work the second time you press the button. I about had a heart attack. I thought maybe I hadn't pressed it good, but I didn't have this command in here. So let's download that. Okay, now it's going that way. Now watch, I'll press it one time. Boom, it changed direction. Boom, it changed direction again. Now, if I press the button and hold it, it'll change direction one time, okay? And when I let it up, it doesn't change direction because we're looking for that 1 to 0 transition, right? Okay. I can press it fast, press it slow. It works every time. Okay, guys, leave me a comment down below. Was anybody able to do this project on their own? Were any of you able to do this project on your own? Because I gave you everything. If you're following these lessons along, you should have been able to figure it out. Even though I did something really clever on the toggle here, in the way that I just made motor direction is motor direction times -1. If you had watched lesson number 34, was it lesson number 34? I keep forgetting what lesson we're on. Yeah. If you had watched lesson number 34, you could have kind of figured out how to do this. But leave me a comment. Was anybody able to figure out how this thing worked? You guys think about giving me a thumbs up on this video. Was anybody able to do this on their own? Was anyone out there able to do this on their own? Or did everybody just copy me? Okay, did everybody just copy me? Leave a comment, let me know. Think about subscribing to the channel. Think about sharing this with other people. This is Paul McWhorter from toptechboy.com. I will talk to you guys later.